Good evening, am I audible? Am I audible? Okay, I will start the session. So today's session is on Supermesh analysis. So let us see what is meant by Supermesh analysis. So if we have a circuit, as it is shown here, so if we have a circuit and in this circuit, if you carefully observe, there is a voltage source. There is a voltage source and R1, R2, R3 resistors are there, and there are two loops here, or two meshes I can say. Two meshes are there. In between two meshes there is a current source. Okay, so in between two meshes there is a current source. If we have a circuit in which any two meshes have current source in between, means a current source is common to two meshes. So two such circuits, if you want to simplify or if you want to determine the currents, mesh currents in such circuits, we have to apply supermesh analysis. So a supermesh results when two meshes which have independent or dependent current source in common. So here you can see mesh 1 and mesh 2. So in between these two meshes there is a common current source. If such circuit is there, then in such circuits we have to apply supermesh analysis. So there are some steps that are to be followed. I will just directly go to the numerical problem and I will explain how to implement supermesh analysis. So here you can see I have taken the same two loop circuit. So in this circuit there is one voltage source, and in mesh 1 9 ohms resistor is there, in mesh 2 3 ohms resistor and 6 ohms resistor there. In between mesh 1 and mesh 2 1.5 amperes current source is there. So here in this question they have asked us to determine the mesh currents I1 and I2. Okay, so whenever it is mentioned mesh currents, we have to apply mesh analysis. Okay, so same method we have to follow which we follow for mesh analysis, same method, but there will be a difference, a small difference will be there because of this current source which is in between two meshes. So let us solve this numerical problem. I'll just copy that figure here. Okay, I have copied it. So you can see here, let us assume a node. I have mentioned node A, so I will just assume a node here, node A. Okay, so this is my node A, and this another node, this is my reference node. So we always know at the reference node the voltage is reference node voltage is 0. So I have assumed a node here. So if you observe here, this is mesh 1, mesh 2, so if you observe here, I have assumed two mesh currents I1 and I2. Okay, so I1 and I2 I didn't assume. Already in the question itself they have mentioned I1 and I2 currents. So I1 and I2 currents are there. So if you observe, just I have assumed both the currents in clockwise. So I'll just erase and I will just see these are the loop currents or mesh currents. So I1 current is flowing like this, I2 current is flowing like this. You just observe besides to this current source whose magnitude this I current is flowing downward, isn't it? I current is downward. This is the arrow mark. So this is the magnitude of this current source is I. So I1 current, if you observe, the I1 current is downward. Okay, I1 current is downward. What about I2 current? It is upward. Okay, so I can say I1 and I2 currents are opposite to each other. So the what to say, this differential current, okay, differential current uh, will flow in the middle branch. Usually in mesh analysis, that's what we assume, that differential current will flow in the middle branch, because both the currents are opposite to each other. So I think I copied the wrong circuit. I just copied that theoretical circuit. So here differential current, so I1 and I2 are opposite to each other. I1 is downward, I2 is upward. So the source current direction is similar to your I1 current. So difference of I1 and I2 current will be equal to the current source current value. Okay, so we already know in mesh analysis, when we write the mesh equations or loop equations for the middle branch elements, we assume that differential current, if the currents are opposite to each other, both the mesh currents are opposite, then we will assume differential current. So similarly here also I have assumed the differential current will be equal to the current source value. So what is the current source value? 1.5 amperes. So consider it as our equation 1. Okay, I hope you have understood. I1 is downward, I2 is upward. So difference of these two currents is equal to 1.5 amperes. Now I will remove this. Okay, so now let us whatever current source is there here. Okay, so let us assume that voltage across that particular current source is V. So I think somewhere I have mentioned, yeah, see here in this circuit. So I am assuming voltage across this current source as V. So assuming voltage across this current source V, now let us apply KVL in this given circuit and let us write the KVL equations. Okay, so I have assumed the voltage across the current source as V. Now apply the KVL in loop 1 or mesh 1. So I will write mesh 1 here so that it will be more clearer to you. I didn't write. This is mesh 1. Okay, so apply KVL in mesh 1. So if you apply KVL in mesh 1, see, this is the voltage across this current source V, and this is this current source voltage. So we have in this mesh there are two voltages and one resistive element. Okay, so total three elements are there. So what I have done here is, see, this is my positive terminal, so current from the source will go upwards, and here this is plus, this is minus. Okay, so these are just the assumptions of this voltage that we have assumed. We have assumed some voltage across this current source of 1.5 amperes. I have assumed positive terminal up and negative terminal at the bottom. So your wish, assumptions are always our wish, but in whichever direction we want, we can assume. So according to me, according to my assumption, I have assumed a voltage V across this current source whose positive is upward and negative is downward. So definitely the current should come out of, if this is a source, for example, okay, just assume if this is a source, current should flow in this direction, and from this voltage source definitely current will flow in this direction. That means both the voltages are in opposite direction. Therefore I have written 12 minus V is equal to, what is the voltage drop across 9 ohms? 9 into I1. voltage drop across 9 ohms is 9 into I1. So just have further simplified it. I have written in terms of V is equal to 12 minus 9 I1. So consider it as your equation number 2. Now let us go to mesh 2. This is our mesh 2. So this is our mesh 2. And this mesh 2, if you see how many elements are there, voltage, resistor and resistor. Okay, so see here, actually there is no voltage source here. This is a current source, but I have assumed, okay, I have assumed there is a voltage across this current source V. Okay, it's just an assumption. Based on my assumption, I'm writing the KVL equations. So there is V, there is 3 ohms resistor, there is 6 ohms resistor. So V is equal to algebraic sum of voltages. So only V is there. So V is equal to, apply KVL in this mesh 2. So V is equal to what? 3 into I2 plus 6 into I2. So V is equal to 3 into I2 plus 6 into I2. Just simplified, you will get V equal to 9 I2. Okay, so we have got two expressions. Okay, in equation 2 and equation 3, if you observe, V is common. So you can equate equation 2 and 3. Okay. Okay, here I have done solving equation 2 and 3. Means I have equated equation 2 and 3. I have got an expression 12 is equal to 9I1 plus 9I2. Okay, so 9I1 by simply by solving equating these two equations, equating equation 2 and equation 3. Okay, I have got this expression. Okay, I will just expand this font size. So this is it. So I have, by just simply equating 2 and 3, I have got 12 is equal to 9I1 plus 9I2. So consider it as equation number 4. So this was our method 1, in which we have assumed voltage V across what? Across the current source. Okay. Now let us go to one more method. Okay. So in the second method, what we are going to do is, we are going to remove the current source. Okay, so we will remove the current source. So I don't have any other diagram in which I have removed. Okay, so I will just remove it. Wait. Okay, so what did I do now? I have simply removed the current source here. Okay, so I have removed the current source. So what has happened here? Now this circuit has how many loops or how many meshes? It has a single mesh. I didn't remove this I1 mesh current and I2 mesh current, which were earlier, they were there. I have left them as it is, but I have simply opened the current source. I have open circuited the current source. That's it. In method 2, in method 1, I assumed voltage V across the current source. In method 2, what I am doing here is, I have just opened the current source. Now I will copy this image and I will write the equations. Of course, I have already written the equations. Okay, so this mesh, which has, by opening the current source, the mesh that I have obtained here, this mesh is known as super mesh. Okay, this mesh is known as super mesh. Okay, after removing the current source. Now applying KVL in this super mesh. Okay, so how many sources are there in this super mesh? Only one voltage source. So 12 is equal to 9 into what? 9 into I1. Voltage drop across this resistor, 9 into I1 plus 3 into I2 plus 6 into I2. Okay, simply open circuit the current source. this mesh will become super mesh. Apply KVL to that super mesh and write the KVL equation. Okay, you will get equation number 5. Okay, now we have done, we have followed two methods here. In one method, what did I do? I have simply assumed voltage across in method 1. What did I assume? I have assumed voltage across this current source. In method 2, what did I do? I have open circuited the current source. And if you observe your equation 5, which is there, you just observe this equation 5. What is it? 12 is equal to 9I1 plus 9I2. You just compare it with your equation 4 of your method 1. What did you get in your equation 4? 12 equal to 9I1 plus 9I2. So you have got the same expression, isn't it? Your equation number 4 and equation number 5 both are same. So now let us determine the mesh currents. So solving equation 1, we just consider equation 1 and either equation 4 or 5. You either consider, we need at least two equations to solve, isn't it? We have two unknown parameters. Okay, I1 and I2, two mesh currents we have to determine. So consider equation 1 and you either consider 4 or 5 because both are same. Okay, and if you have a scientific calculator, what is our equation 1? If you remember, do you remember? This is our equation 1. Okay, I1 minus I2 is equal to 1.5 was our equation 1. Now apply Kirchhoff's, of course, we have applied Kirchhoff's voltage law and we have written the expressions. Now take a scientific calculator, substitute equation 1 and equation 4 or 5 and you will get I1 equal to 8.5 amperes, I2 equal to minus 0.0833 amperes. Okay. So simply if you have a scientific calculator, you can go to equation mode in that scientific calculator. You substitute the coefficients of I1 and I2. You will get I1 and I2 values. Okay. So let us go to another numerical problem. So here actually what I have done is I have already written the mesh currents. I will remove those. So this is the given circuit. In this we have to find the mesh currents I1, I2 and I3. So you have to find the mesh currents I1, I2 and I3. So we have to go for first thought that comes to our mind. If it is mentioned mesh currents means loop currents. So first thought that comes to our mind is that we have to follow mesh analysis or Kirchhoff's voltage law. That's what comes to our mind. So you just observe the circuit. There is a voltage source. There is a resistor in this branch, resistor in this branch, resistor in this branch. There is a resistor in this branch. There is a resistor in this branch. But there is a current source between two meshes. So if there is a current source between two meshes, that means that it is a, we have to apply super mesh analysis to simplify the circuit and to determine the unknown parameters. Okay, so that thing you have to first of all identify whether the circuit that is given to you is normal, means in that particular circuit whether you can apply normal mesh analysis or super mesh analysis. Okay, depending on the location of the sources. Okay, so if current source is there between two meshes, okay, here how many meshes are there? You can mention in the chat box. If I ask something, you can mention in the chat box. How many meshes are there? Mesh 1, mesh 2 and mesh 3. Total 3 meshes are there. Okay, notations are your wish. Okay, I have assumed the first one as mesh 1. You can assume this as mesh 1, your wish. Okay, who is going to ask? Sorry. Okay, notations always, assumptions. If any assumption is there, your wish, you can assume anything. There is no particular sequence that is to be followed. Okay, you can assume any, you can give any notation to any mesh. Okay, so any of these three can be your mesh 1, mesh 2, and mesh 3. Total 3 meshes are there. Okay, so now let us solve this circuit, and from this, based on the location of this current source, I have come to a conclusion that I have to implement supermesh analysis. So let us see how to implement supermesh analysis. I have written mesh 1, this I have written considered as mesh 2, this I have considered as mesh 3. And if in the question itself, if they mention the loop currents, that is okay. Even if they won't mention, you assume your own loop currents, okay, or mesh currents. So I have assumed all the mesh currents in clockwise direction. Just observe, this is clockwise, clockwise. This is also in this mesh tree also I have assumed clockwise direction. So all the currents are in clockwise directions. Okay. Now first of all, look at the current source. It is in between mesh 1 and mesh 3. Current source is in between mesh 1 and mesh 3. So I just observe the current in mesh 1, it is downward. Current in mesh 3 is upward. Isn't it? Current in mesh 3 is upward. So how to know whether the current is downward or upward? Based on how you just draw this complete circle. See, current is in clockwise, so this side it will be upward. What about this I1? This side it is upward, but this side, which is the side nearby to this current source, so this side it is downward. This side is I3 is upward, I1 is downward. Okay, so I1 and I3 both are in opposition to each other. Both the currents are opposite to each other. So differential current I1 minus I3 or I3 minus I1, your wish. You can even write I3 minus I1. It's not wrong. Okay, because we don't know the value of I1 and I3. So we can write either I1 minus I3 or I3 minus I1. So I1 minus I3 is equal to 3. Okay, so why this minus? I hope you have understood why we have put minus here. Okay, so I1 and I3 are opposite to each other, and current source is between mesh 1 and mesh 3. Therefore, I1 minus I3 is equal to 3. Consider it as equation number 1. Okay, now I am going to follow, in the previous problem I told you two methods. Okay, so here in this second problem I am going to follow method 2. So in method 2, what did I do? I have removed the current source. Okay, so if you observe here in this problem, along with the current source, in series to the current source, there is a resistor, isn't it? In series to the current source, there is a resistor. So whenever you are removing the current source, whichever element is there in series to that particular current source, it is also to be removed. You have to remove that element also. So you have to remove 3 amperes current source as well as 2 ohms resistor. Both elements in that particular branch, okay, are to be removed, open circuited. So this is it. I have removed both current source and resistor. So now how many loops do I have, or how many meshes do I have? I have only 2 meshes, but you should not remove these loop currents or mesh currents which you have assumed before removing the current source. So they must be kept as it is. So I1 and I3 should be left as it is. Now we can apply Kirchhoff's voltage law. I will just copy that image in this slide. Okay, so here in this circuit actually 2 meshes are there. So this particular mesh, this dotted line which is mentioned here, this is our super mesh, and this is normal mesh. Okay, this is super mesh. This particular mesh is super mesh. Now let us apply KVL in which mesh? I'm first of all applying KVL in super mesh. So which is in which I1 and I3 are there. So how many sources are there in this mesh? Only one source is there, 8. So 8 is equal to, so from 8 I am moving like this in clockwise direction. There is a 2 ohms resistor. 2 into 2 ohms is in between I1 and I2. I1, I2, how are they? I2 is going up, I1 is going down. Oh wow. Okay. So both are opposite to each other. Therefore, 2 into I1 minus I2 plus one more element is there, 4 ohms. 4 ohms is in between this mesh and this mesh. So both two currents are there. I2 current, it flows like this. I2 current is flowing like this. I3 current is flowing like this. So both are again opposite. So 4 into I3 minus I2 plus one more element is there in this super mesh. That element is 2 ohms. So 2 ohms, only I3 current flows through 2 ohms. So voltage across 2 ohms is 2 into I3. So I hope you have understood. You must know KVL, KCL, mesh analysis. And I have simplified it. I have got an expression 8 equal to 2I1 minus 6I2 plus 6I3. Now let us apply KVL in this mesh. So is there any source? There is no source. So 2 into 3 elements are 2 ohms, 6 ohms and 4 ohms are there in this mesh. Okay. So what is the voltage across 2 ohms? Voltage across 2 ohms is, we are in mesh 2. Okay, we have applied KVL in mesh 2. So I2 and I1, earlier I have told you I2 is going like this, I1 is downward, I2 is upward. So I2 minus I1, 2 into I2 minus I1. Next, one more element is there in mesh 2, 4. 4 into I2 is going like this, I3 is going like this, both are opposite. So 4 into I2 minus I3 plus one more element is there in this mesh, 6 ohms. So 6 into I2. Okay. So just simplify, you'll get 0 is equal to minus 2 I1 plus 12 I2 minus 4 I3. So I'll remove this. Okay. So consider the first equation, which is the KVL equation for when you apply KVL for this super mesh. Consider it as equation number 2. When you apply KVL for mesh 2, consider it as equation number 3. Okay. Now you have three equations. Equation 1, 2 and 3. You have three equations. Now use a scientific calculator. Use a scientific calculator. Substitute these three equations. So what is our equation 1? So this is our equation 1. Okay, I1 minus I3 equal to 3. Next equation 2 is this one. 8 is equal to 2I1 minus 6I2 plus 6I3. Next, third equation is 0 equal to minus 2I1 plus 12I2 minus 4I3. Substitute these three equations in your scientific calculator. You will get I1, I2 and I3. So I have got I1 as 4 amperes, I2 as 1 ampere, I3 as 1 ampere. Okay. So let's solve one more small numerical problem and conclude this topic. So in this numerical problem also, we have to determine the mesh currents I1 and I2. Okay. So I1 and I2 mesh currents we have to determine. So earlier it was there, I1, I2 mesh currents were there. I have deleted it. So sometimes, in the numerical problems they give mesh currents. Unnecessarily I deleted it. It is already mentioned I1 and I2 mesh currents. Okay. So you have to determine. If it is already given in the question, it's better. Even in the previous problem also unnecessarily deleted, it's okay. So mesh currents, if they won't give, you have to assume. Okay. So here if they give, it's okay. So now, so if you just you can go for any method, either method 1 or method 2. Okay, you can follow any method. So here in this numerical problem, I first of all I have assumed voltage across this current source. You just see here, of course, we are solving numerical problems on supermesh analysis, so definitely the current source will be in between the meshes. Okay, so here two meshes are there, so I have assumed voltage Vx between mesh 1 and mesh 2. So you just observe the current mesh current directions. I1 is downward. What about I2? It is upward. I1 and I2 are opposite agents. So I1 minus I2 will be equal to what? Current source value. What is current source value? It is 1 ampere. So did I write that? So here I have written it. See here. Where is it? Pen. Yeah. So I1 minus I2 is equal to what? 1. I1 minus I2 is equal to 1. So I have rearranged the terms. I1 is equal to 1 plus I2 I have written. And since I have assumed Vx here, okay, Vx is the voltage across this current source. I will just copy in the next slide to write the KVL equation. So I will apply KVL to both mesh 1, to both mesh 1 and mesh 2. So see here, applying mesh current, what to say, KVL in mesh 1. So apply, so just observe mesh 1, 21 volts, Vx and 6 ohms. That's it. 3 elements are there to act. Okay. And the positive of Vx is upward, positive of the source is upward. So currents will be opposite if they are coming out of this. So both are opposite. So 21 minus Vx is equal to voltage drops in the passive elements. So only one element is there, 6 ohms. So 6 into I1. Okay. So 21 minus Vx is equal to 6 into I1. Vx is equal to 21 minus 6 I1. I have considered it as equation 1. Now applying KVL in mesh 2. So in this mesh 2, what are the elements? Vx, 4 ohms resistor, and another one more voltage source is there, 5 ohms voltage source. So you just observe from positive, from this plus current will flow like this, from this plus current will flow like this. So see, they are just in sync with each other, means those two currents coming out of these two will be adding up. So 5 plus Vx I have written. 5 is what? 5 is the So 5 is the voltage source value. 5 is the voltage source value. Okay. So 5 plus Vx is equal to what? Voltage drop across only one element is there, 4 into I2. So Vx is equal to 4 I2 minus 5 I have got. So now you just compare this. I will just delete this circuit. Equation number is not visible. Okay. So see here, you can compare equation 1 with the equation 2. Vx is equal to 21 minus 6I1. Vx equal to 4I2 minus 5. So just equate those two, equation 1 and 2. So and simplify, you will get equation 3, that is 6I1 plus 4I2 is equal to 25. So consider it as equation 3. 6I1 plus 4I2 is equal to 25 as equation 3. Okay. Now this equation, which is equation 4 here, that I already told you at the beginning. What did I tell? I told you that difference of I1 and I2 is equal to current source value. I1 minus I2 equal to current source value is 1 ampere. So just I have rearranged the terms. I1 equal to 1 plus I2. So you consider it as equation 4. Okay. So now I'm going for supermesh method. So in the supermesh method here font size. So I didn't get enough time to what to say write and rearrange the content. Okay. So here once again I'm going for supermesh method. So I have removed the current source here and I have considered supermesh. So now I'm going to apply KVL here and I'm going to apply KVL and I'm going to write the KVL equation. I will just copy this circuit in the next slide. So I have already told you there are two methods that are to be followed. You can follow any method. Okay, you can follow any method. Either you can assume voltage across the current source or you can simply remove the current source and go for the supermesh method. Now apply KVL here, 21 and 5 volts they will add up because this current coming out of in this direction from this source current will flow like this. So both will add up. 21 plus 5 equal to 6 into I1 plus 4 into I2. 6 into I1 plus 4 into I2. So just simplify it. You will get equation 5. That is 26 is equal to 6 I1 plus 4 I2. Now you just substitute your equation 4 in 5 and just simplify. You will get I2 value. That is 2 amperes. Okay, I'm not reading out the equations. Somebody had some issue with reading out that. No need to read each and every step. The reason behind that was in the last session I just wanted to um, what to say give some time to write the equations to you people. That's why I was reading each and every step. Now I don't have enough time to read, so simply I'm telling you how to write the equation, what is the answer that you are going to get. Okay, now you have got I2 value. You just substitute in your equation 4. Where is it? You will get I1 value. Okay, this is I1 value that we have got. Okay, so I1 and I2 are the mesh currents for the given circuit. Now I will just close this session and immediately I will start the another session. Okay, just leave and rejoin the next session. I won't take more than 15 minutes for next session. Okay, I will conclude within 15 minutes. So just leave and rejoin. It's next. I want to separate these two topics. Okay. If you have doubts, you can mention in the chat box. I will clarify the doubts later.